Alright, so we're looking at section 6.3, which is on page 167 in our student journal. What we're going to be talking about today is how to find the inverse of functions. We've done inverses before. We've done the inverses of linear functions, quadratic functions, cubic functions. And if you recall, here's the method that we use to find the inverse. We have to say, to find the inverse, we switch x to y and y to x, and then solve for the new y. That's the way we found inverses for everything, every equation that we've worked with. So let's take number 1. We have y equals 6 to the x. We're trying to find the inverse of it. So to find the inverse, we switch the y to x, then the x becomes a y. So this would be the inverse. But if I wanted to put this into my calculator, I can't do it. To put something into the calculator, I have to have it in y equals form. So to be able to do that, to put this into the calculator, I'm going to rewrite this inverse in a different form. I'm going to write it in log form. To write this in log form, I find the base. Here's the base of the exponent, so it's also the base of the log. So it would be log, here's the base, swirl it around, of x, back over to here, equals y. And so this is going to be the inverse of it. Y equals log base 6 of x. So that means that that's going to be the inverse of that original function. If we're not sure about that, we could graph them. Because if you look up here, if you have a function and they're inverses of one another, they're going to be reflections over this line y equals x. So if I graph the first one, and if it looks like it's a reflection over the line y equals x, we probably did it correctly. So if I'm going to put this into the calculator, I'm going to have to put in 6 raised to the x. I don't have the change of base on my calculator, so I have to do log x divided by log 6. If you have that change of base, you could just put it in the way that you normally do. I'm going to do a zoom. I'm going to do a zoom square this time. Here's what 6 to the x looks like. And here's what my other function looks like. And can you see how those are reflections over that line, y equals x? It's been reflected right over it. And in fact, if I look at the table of values, I can look at some points. Here's a point 0, 1. So on my other one, I see the point 1, 0. Here's a point 1, 6. So on my other function, I should see the point 6, 1. And I do. Okay? Oops, I don't want y3. There we go. So that's how we can find the inverse. If it is an exponential, I change y to x, x to y, and then I just rewrite it as a log, and then we're finished. So now let's do this one. So we're going to do the same thing to find the inverse. Y becomes x becomes y. Now this one is a log to begin with. So how do you think I want to rewrite it? As an exponent. So to rewrite this log as an exponent, what's the base? E. So I find the base is E, and I'm just to rewrite it, I'm just going to swirl it around. So my base is E, here's the power, equals y plus 3. But I want to get it into y equals form. So what would I have to do to get it into y equals form? Subtract 3. So I would get y equals e to the x minus 3. That's going to be the inverse of it. Alright, so same thing here. Y is going to become x. X is going to become y. But this is not in a good form. We want it in y equals form, so we have to rewrite it. How would I rewrite it? Hunter, do you know? 7 to the x equals y, right? So y equals 7 to the x. That's going to be the inverse. Okay, last one. Y is going to become x. X becomes y. Now, this is an exponential. People get confused when they see the e, but it's an exponential. See, this is the base, this is the power, equals that. Exponentials, we want to turn into logs. And so I'm going to do log. What's the base, everybody? Log base e. So I do log base e, swirl it around, of x equals, come back this way, 6y. What's a better name, though? Instead of saying log base e, what can I just say? Natural log. So natural log of x equals 6y. But I want to solve it for y, so what are we going to do to both sides? Divide by 6. Okay? Any questions on inverses? All right, so those 4 were not too bad, and now we're going to do some that are a little more challenging. So flip over to page 168, and let's take a look at numbers 15 and 16 now. So looking at number 15, I can see this as exponential, okay? I'm going to start off, it doesn't matter, I'm going to change my y to x, my x to y. But here's the little thing that makes this one harder. In order to rewrite this as a log, it has to just be a base to a power. So what am I going to do if I just need a base to a power? I don't want that there, so what are we going to do? Yeah, just subtract 10 from both sides. So now we have x minus 10 equals 15 to the y. So now we have that base to a power like we need. So what do I do if I have exponential? How am I going to rewrite this? As a log. So it's going to be log, find the base, log base 15, swirl it around, back this way, and so there's going to be the inverse. Suppose I'm not real sure about that. Maybe it doesn't feel like it's the correct answer. Well, let's graph it and see. The original is 15 raised to the x plus 10. And the next one I have is, for me, I'm going to have to type it in log of x minus 10 divided by log of 15. And I'm not sure I'm going to be able to see this graph because this has been shifted up 10 units. I'm going to have to change my window. I'm going to make this go up to from negative 30 to 30. We'll see what this does. So here's my original function, and then here's the inverse. Oh, there's y equals x. I'm like, that's not the inverse. Here comes the inverse. Maybe. Did I have it graph the inverse? Maybe it's scooted down there too far for us to see it. Let's see. So there's the original. Y equals x. You know what? I think it's graphing it, but it's just so close to the axis that we're not really seeing it. Yours looks better. Yeah. Okay, so it works. We're good. Alright, let's go to number 16 now. So same thing, x becomes y becomes x. But this is the same kind of problem, because I can't do my base raised to x and bring it back to that. I need to get rid of this first. See, wherever we're going to be starting, like this is our base and this is our base, that has to be by itself. So I would have to add the 8 over. So we're going to have x plus 8 has to equal this. Remember, if we don't see a base, we know the base is e for natural logs. So I'm going to find that base. I'm going to swirl it around so it's e to the x plus 8 equals 2y. But we just want to have y by itself, so I could just multiply both sides by 1/2. Alright? So that's it with inverses. So again, just make sure that you get this natural log by itself, get the exponent by itself, then use your swirling and all that stuff to get it into the correct form. Okay, last thing we're going to do is the graphing. Let's flip back over to page 167 for just a minute. If we're graphing a log function, remember how log functions are inverses of the exponentials. So here's the exponential function, here's the inverse, here's what the log function looks like. Look at this log function. It has an asymptote of x equals 0. What does the exponential have an asymptote of? This line right here, what's that line? Y equals 0. Do you see how they're inverses and y became x? X and y, see, that's still related. So here's the asymptote for the log. Alright, now look at this one. This is if we have a b value for the exponential that's in between 0 and 1. Okay, so for 0 and 1, that becomes a decay function. The inverse is going to look like this. It's still the same kind of thing. Here's the exponential decay function. So the exponential decay has an asymptote of y equals 0. Here's our logarithm, and this is only when b is in between 0 and 1. That's for this. When b is in between 0 and 1, we have the exponential decay, and we have this log function that is now going to look like this. It looks a lot different than the other one. It's going to be this kind of a shape. And so this is going to have an asymptote of x equals 0 still. Alright, so just kind of keep that in mind. If our b value is greater than 1, here's the way the log function looks. If the b value is in between 0 and 1, that's the way the log looks. Now let's come over here and graph some of these. Okay, so to graph this, anytime I want to graph, I need to make an XY chart. But it's very difficult to make an XY chart when I have a log. So I want to rewrite this as an exponential. Can you tell me what it would be as an exponential? What is it, everybody? What's the base? So 2 to the y equals. And in this case, it's easier to plug in for y. So I'm even going to subtract 1 over. So 2 to the y minus 1 equals x. See, this, when I'm graphing logs, it's easier to plug in for y and solve for x. So I'm going to have xy, like this. Now, what's normally our asymptote on log functions? What did we just say it was? X equals 0. But what's it going to be now? What kind of a shift are we going to have? A shift to the left one. So instead of our asymptote being at 0, like it normally is, it's going to be a shift to the left 1 unit. So there's going to be our vertical asymptote now. So that means I'm not even going to be able to plug in anything for x over there. All the x's are going to be over here. So let's plug in a value for y. What's an easy value to plug in for y? 0. What is anything to 0 power? Minus 1 is 0. So I'm going to have the point 0, 0. All right, let's plug in something else for y. Let's plug in 1 for y. 2 to the first is 2, minus 1 is 1, so I have the point 1, 1. Let's plug in 2 for y. 2 squared is 4. 4 minus 1 is 3, so I have the point 3, 2. Maybe I want to test something in here just to see what happens. Let's plug in, what would that be? Negative 1/2. So now I would have 2 to the negative 1/2 power for y. So what does 2 to the negative 1/2 be? What does the negative do? Flips it over. This is actually harder than I thought. This is going to be 1 over the square root of 2 minus 1. That's not really very helpful. Forget it. We're not going to test that. Here's the way it looks. Okay? So there's the way our graph's going to look. All right, let's look at number 18 now. The base on this one is 1/2. That doesn't change our asymptote. Our asymptote is still going to be x equals 0. What does this minus 4 outside of the parentheses do? It shifts the whole graph down 4. So if I have a vertical asymptote of x equals 0 and I shift it down 4, does that change it? No. So here's my vertical asymptote still. Right there at 0. Okay, I want to plug in values to make an XY chart. It's pretty tough to do the way it's written now, so I'm going to swirl it around. I'm going to have, oops, but in order to swirl it around, remember, this would have to all be in parentheses, so I'm going to have to take that over there. I need it like this to be able to swirl it. So I'm going to have 1/2 raised to the y plus 4 equals x. What would be, you guys, 0 is not the best thing to plug in for y on this. What's the best thing to plug in for y? -4, isn't it? So I would get 1/2 to the 0, which is going to be 1. So I know I'm going to have the point 1, -4. Let's see, what else might I want to plug in? I might want to plug in something easy to check. Plugging in 0 for y, 1/2 to the 4th. We'll plug in 0 for y just to see. What's 1/2 to the 4th? 1/2 times 1/2 times 1/2 times 1/2. What is that? 1/16, right? Not a great point. 1/16, 0. Right there. Okay, I might want to plug in something actually lower than -4. Let's look back and see what this is supposed to look like. Remember, this is the way that these graphs look. So we actually probably would just want to test maybe one more point. Something that would make this easier. Maybe if I just plugged in -6 would be a good point. Here's why. -6 plus 4 would give me -2. What's 1/2 to the -2 going to be? What is it? 4, yeah. So that would be a good point to do. So if we plug in -6, we're going to get 4. So at 4, we're going to be at -6. And so here's the way our graph's going to look. Okay? Easy enough? All right. So your assignment's on your assignment sheet. It's also up on the board. And that's it for today. So remember to find inverses. What do? We switch x to y, y to x. If it's written as an exponent, we're going to write it as a and vice versa. Very good.